Hi there, my name's Adam Goodrich and I'm the founder of Procedural Worlds. In this presentation, I'm going to talk about world creation for AI and machine learning in Unity 3D with Gaia ML and the Intel Game Dev AI Toolkit. First, a little bit about Procedural Worlds. We are a Unity Asset Store publisher and we make tools and offer services to create environments for games and simulations. We broadly break our toolkits down into Create, which is all about world creation, Connect, which is about connecting people together with social experiences, and Scale, which is about making Unity run well and at scale. When considering how to build intelligence into games and sims, there are a number of areas where AI and machine learning can create value for games and experience developers. First, in the area of content creation, AI and machine learning is making massive bounds in the constructions of realistic environments and humans. In terms of graphics quality, AI is being used to increase the resolution and the visual quality of the experiences you're having. In the area of game AI and testing, AI is being used to provide better experiences for players through smarter NPCs, character controls and animation, and automated testing. And finally, in the area of game assistance, AI is being used to create new experiences for players and streamers, anti-cheats and anti-toxicity. This is just a small sample of how AI can be used in games. So in this presentation, I'm going to talk about Gaia ML and the Intel Game Dev AI Toolkit version 1. This is a framework to facilitate the exploration of AI and machine learning with Intel's OpenVINO and Unity's Barracuda in Unity 3D. The toolkit consists of two major components. The first is Gaia ML from Procedural Worlds, and what we've done here is we've integrated Intel's OpenVINO and Unity's Barracuda inference engines into our world building suite. The idea here is to give you some great tools within which to start your exploration of AI and machine learning in 3D environments. With these tools, we provide samples for style transfer and object detection. At a high level, Gaia ML offers an inference wizard where you can embed your own machine learning experiments within Unity 3D. Inside of Unity, we have Gaia ML, and then we have our inference engines, OpenVINO, Barracuda, and coming soon, DirectML. And then within that, you can create your own user configs and automate the experimentation and application of machine learning in your environments. Okay, so let's do some demos. First, I'm going to show how Procedural Worlds tools can create rich environments in minutes. Then I'll show off Gaia ML and the Intel AI Game Dev Toolkit with style transfer, object detection, and an example of a game which is a rail shooter with an AI controlled ally which is using object detection to detect its enemies. To get your copy of Gaia ML, you can go to the Intel Game Dev AI Toolkit webpage, and you can then click through to grab Gaia ML from Procedural Worlds. You'll be taken to our Canopy website and our library page where you can see a tutorial and how to get started with it, and also some documentation which give you a bit of a sense how to set it up. From here, you can go to the downloads page, and we'll go to our AI Game Dev Toolkit downloads page, and you can click in and download your copy. Then finally, for support, you can go to our forums pages under Toolkit, AI Game Dev Toolkit, and to ask questions, you can ask them here and we'll look after you. So here I have Unity, and now I'm going to use Gaia to create a world. Go Window, Procedural Worlds, Gaia, Show Gaia Manager. Gaia is wizard driven and handles most of the heavy lifting of creating environments for you. So Gaia will take you through a process where you set up your project, create your world, create your runtime, which is the ocean, skies, weather, and so on. Add in your inference, and then build and deploy. So we've already set up our project. Now let's create our first world. Gaia gives you complete control over how you want to create your environment. We have a bunch of predefined settings for you, or you can go in if you know what you're doing and change these things yourself. In this case, I'll choose a large world. I'm targeting it at desktop. I'm going to use the Gaia Pro sample biome. Gaia ML comes with some great starter biomes. A biome is a set of assets and the rules by which those assets are placed into your environment. Gaia ML is completely unlocked, so you can add in your own assets and create your own biomes, or if you prefer, you can use the pre-made biomes that come with Gaia Pro or buy some of our other predefined biomes. So in this case, I'm going to choose the Gaia Pro sample, and the workflow I'm going to use here is our world designer, which will do a directed random process, or I could alternatively manually control this completely myself. For the sake of time, let's go with World Designer. Just close the manager. So what World Designer has done is given us a low fidelity preview of the environment that it's just going to create for us. If we wanted to, we could go and customize how Gaia generates this, and we could also choose the different styles and frequency of features that are applied into our environment. But this actually looks pretty nice. We've got some nice flat areas and some nice mountains. So I'm just going to go generate world. The next part of the process is to add our runtime. This just automates the setup of skies, lighting and water and so on. So I'll pop this out of the road and let's watch the magic happen. Okay, let's zoom in a bit. And here you can see we've now got an environment that's been nicely lit. Okay, now that we've got our environment, let's add some more features to it. Let's go over here and we'll go into Gina and we're going to spawn in a little town. Place that there. So this is another tool of ours, Gina, and this allows you to pseudo procedurally add all sorts of different things to your environment. That'll do. Now the next thing we'll do is we'll connect this all up with roads. So we'll use Gina for that. Gina, add road. And I'm going to tell Gina when it creates our road to use path finding. So it'll try and find the minimum path or gradient to get between the 2 points. So we'll just go and click here. So now we've created a nice road network. The next thing I'll do is I will carve our road network nicely into the terrain, because as you can see, the terrain doesn't know anything about our road. Nice road. Good. Let's add some street lamps. To finish this off, I'll go back to Gaia, go back to my biome here, and I'll go spawn biome. And this will run through all these rules and apply these into our scene. Okay, so let's press play. So here we have a nice environment within which to start to run our machine learning experiments. Okay. So the next thing I'd like to do, now that I've created our environment, I'll just save my scene. Now let's add some style transfer to our project. I'm going to go to Manager, go to over to the Inference tab, and the inference settings that you see here are actually picking up the scriptable objects that have already been pre-configured and added into your project. The idea here is that for your own models, you can create predefined settings and then easily expose them in the Gaia user interface. So let's go and look at our style transfer for Barracuda. Here we've got the main camera, the compute shader that's doing the image processing, and then the actual models themselves. So if we go into here, then click onto this, you can see the model information that is going to be run when we add style transfer to our scene. So let's go ahead and do that. I'm just going to go apply now. Boop. And what Gaia has done is it's pre-configured this model into my scene and it's all ready to go. So let's just press play. Here we have style transfer running in real time in our scene. Now in this demonstration, We are using Barracuda, and if you have Intel hardware, for example the Arc GPU, then there's a beautifully optimized version that runs with OpenVINO as well. Sweet. So there I've demonstrated how to create a world with Gaia ML and how to use the pre-configured settings to add inference into your world. Now for the next demonstration, I want to show you something a little bit more sophisticated. What we've got here is another environment which we've created in Gaia, and we've added in our rail shooter game template, which is a little game template to create a certain genre of game. Our rail shooter is this object just here. If we go in, we can see we've got a little game manager, some music, and the player controller, and this controls our ship through the scene. What we've also added is an ally controller. This is what we call our loyal ally. So the loyal ally has been set up to use object detection using YOLOX to find and then select targets to attack. So in this scenario, we're using object detection to choose what the game's going to do. The objects that it's going to look for are these little ships here. We've also got our inference manager, and you can see that we're using the Coco YOLOX nano model, and we're running this on the GPU. So let's press play and quickly head out to sea. I'm going to zoom out a bit so we can see a little bit more of what's going on. And I'll just keep heading out to sea here, and in a second our little loyal ally will catch up. Just wait for him. Should be here any second now. So what you can see here is the red box is where the ally is choosing to aim for, and the blue boxes are the choice of targets. So every time he kills a target, he basically uses object detection to choose when his next target should be, and then makes his own choice as to which one he'll attack. So what we've got here is a rather neat example of using object detection in a game to influence the gameplay. Now to finish off, let's get a sense of what's actually going on here. So if I go to my ally controller and look at my ally bounding box script, and let's just go and edit this script. So at the start we set up our object, not too much interesting going on here. So what we are doing in our update loop is, first of all, we clear out any of those blue boxes. Those blue boxes signified that there was a potential target, and once the time has expired, we clear them out. Then we make sure that we don't have a target, and if we don't have a target, then we look through each of the objects that the inference has detected for us. We check to see if it's active, and then we create a bounding box for it and shoot a ray cast out to find out what that object is in the scene. Then if we get a hit, we check the object type, and then if it's approximately the type we're looking for, and this model wasn't well suited for the sample assets we used, then if its attack confidence is great enough, so if we're confident enough that it's one of those things, then we add that enemy to our target candidate list. Then at the end of that process, we check each of our enemies and we choose one of them. And then the game disables the inference, goes ahead and shoot down the enemy. And at the end of that process, it re-enables inference and starts the whole thing again. A pretty cool example of how you can use machine learning and object detection to influence your gameplay. The last thing I wanted to talk about is how you extend this to create your own settings. What you basically do is you grab your inference feature class, you extend that class, and you implement your own methods within that class to provide that custom capability that you want. Because they're derived from scriptable objects, you can add in your own variables and any other settings you want here. And then to configure them, you just instantiate an instance of that scriptable object and plug in your settings as you prefer. When you've instantiated a scriptable object from that base class, then the interface inside of Gaia will pick that up and expose all the settings that you've set up in your project. If you'd like to learn more, then feel free to reach out to me at adam@procedural-worlds.com. Thanks for watching.